Hello everyone and welcome to this video. And in case you've been following my previous videos, well, thank you and welcome back. And special thanks for those who are liking and subscribing. These really mean a lot. So today I want to discuss one of the GeoAI advanced topics, I'd say. I've been publishing a bunch of different tutorials or demos on how can we work with AI in general in ArcGIS and in GeoAI in specific. And today I'm going to be focusing on a topic in GeoAI that is specifically around extracting trees or classifying trees. This is a bit of a long process that I've been going through for the past, I'd say, a couple of weeks, testing and doing different workflows, and it's a really longer workflow. So I'm gonna be sharing it in parts and expect other videos to come to complete the story. Today, the main focus is really data prep and imagery per se, which is very essential for any GeoAI workflow or AI workflow. Data, what you feed in, is the most important part. And for instance, today, I'm gonna be really showing a challenge that I've been facing. I was working on extracting trees from an informal settlement context, and these trees are most of the time overgrown, there's shrubs around them, there's ground covers, and it's a bit of a challenge to extract them from RGB imagery. Tried different models, because always I try to use the least input possible, that's the most efficient. But sometimes it just doesn't work, and this was a use case. So as I was looking at these trees and looking at my RGB, I thought that if I bring in elevation data, I'll be able to see these trees in a better way. I'll be able to extract them, label them first to train a model, and then extract them. So what I'm gonna show in this part of the video is really working with RGB bands and a separate digital surface model, or DSM as I'm going to be calling it, and a digital terrain model, or DTM. I'm going to be going through these inputs and try to prep them, play with them a little bit to get really deep learning input ready data sets that I'm going to be using in the workflow. So with no further delay, let's jump to the video and see how this is done. So if you look at the screen, we'll see a normal RGB image. We've got an orthomosaic. This is coming from Alexandria, South Africa, delivered with South Africa Flying Labs. And I really want to start exploring the challenge I was telling you about. So I'm just going to zoom into really any area. And look at this. It's pretty hard to decide if this is a tree, or this is a tree, or this is a tree. Well, this is a tree, but where does it end? It's a little bit challenging, and I think that's a limitation of RGB whenever we're dealing with such data, such context. Therefore, I'd like to explore other layers that are available. If you have a drone, you fly over a certain area, you put that data through side scan, you'll get an RGB, a DTM, digital terrain model, and a DSM, digital surface model. Let's start with the DTM. This is going to be essential for us. You see it varies between 1396 and 1448 meters above sea level. I'm gonna switch this guy on and switch this guy off and zoom out a little bit. Indeed, I can see a normal digital terrain model in there. Note this is 2.5 centimeter imagery, by the way, and I'll be showing that in a moment. Now I can also go and switch on the DSM, and this is a very interesting point. Anytime you load something and you see this, it means there's something wrong, not in the data, it's just how the data is added in. It might need a simple click of dynamic range adjustment. So I'm gonna navigate to raster layer and click DRA. And this will take a moment, but there you see, my DSM is in there, and I can see the surfaces, I can see the heights of things and where they are. The first I'd like to get out of these two is a normalized digital surface model, starting from 0 elevation and going up to my max. So therefore, to do so, there's multiple ways. You can create processing templates, you can work with raster functions, directly. So I'm gonna be doing the GUI easy way, and certainly more than happy if you have any questions, want more resources, post them in the comments and I'll follow up on that. From my imagery menu group, I click on raster functions, and in there I want to find arithmetic. That would be the first one I want to use. I'm gonna subtract my DSM from my DTM, and I want to use minus and first off. Please note that none of this will be saved locally. All of this dynamic referencing the data. As we know, when we see this, we shouldn't be scared. We just click the array and problem solve. Now the challenge is, you see the below zero values. I'd like to get rid of this. So the next step is, I'll edit all of this and make sure I have just one raster at the end. In here, I'm gonna look into the next variable, which is less than. I wanna highlight all the zero values, and anything less than zero, make it a zero. So I'll get a constant, put that in my raster too, and the output in here. After getting these, I'd like to make a condition to get a final nDSM where anything below zero is zero, anything zero is zero, and anything above is its true value. So to do that, I'm gonna get another raster function, which is condition. And I'm gonna drop this condition in, drag in the less than is gonna be my input raster. These are the less than outputs, then zero, my true is the zero, and my false is this, which I wanna correct. And then what I wanna do is check, perfect, everything works, auto layout just for some look and feel, close this guy, have a look at the function, and then run the function. If I go and click the array again, notice that now everything is at zero and I'm good to go up from there. Now, if I look into these, we'll come back to the raster function, can already see some trees, right? These are the higher elevations. I'd like to highlight these. I'd like to get rid of all of this because I want a layer, a basic layer that I can use for my training data. I also eventually want to add this to my RGB, but for now, the second part of this video that is coming is really labeling, and for the first step for labeling, I want to make sure I only label right trees. So let's do a small trick in here. I'm gonna edit the function chain again, look into my raster functions, and for now search for remap. All I want to do is get my remap here. I'll connect my last output to my remap and auto layout, and double click this. I'm gonna get any value between, well, anything below 0.5 doesn't really look like a tree. I want to get rid of that. So I'll start from minimum 0.5, and this is the maximum you can choose. I'll go assuming that a tree starts at 1.5. So I'll have these as a class. You can later use these as a shrub class. We're just working for trees. So really the interest for us is 1.5 to 20. And anything, my max is around 17, I think that I saw, so 20 should be fine. And any unmatched data is no data. I want to get rid of it from my background. And I'm gonna click OK. Run this, and let's see, I did a small mistake, right? I forgot to add class 1 for the output of this and class 2. I was like, what is this looking like? Now we'll do this, run it, and we can see something very interesting. If I look into this, I already see two classes, and I'd like to show the background. So let's do this. Gonna open function chain again. Something wrong here. Yes, so I did click this. Things happen. Well, that's what I'm looking for. A final result where I can see trees, they're here, and these are buildings. Buildings aren't my concern for today. I'm just interested in trees. I'll eventually get the nDSM, which we passed through to the RGB, and I'll show you this. But before doing that, let's see a small trick. I wanna look at the trees and make sure I can use this and this together. So a simple trick out there, I'm gonna go to transparency, well, raster layer, it's already selected, and I'm gonna go to difference, which I believe is here. And look at this. Everything that is in purple is a tree. So now if I'm creating labels, I know where to create my labels, and I know that I'm not gonna miss between ground covers and trees. And this is really everywhere. We can zoom to any area around. Let's just pick a random area here, and we can see the outputs. So the next step for here is I want to get back the nDSM, and I want to add this to my orthomosaic and have an output of it. So I'm going to copy this guy and I'm going to paste it. It's a duplicate. First, let's call this the remap for labels. We'll use it later. Switch this off, and let's call this, well, up in here, nDSM. And since I mentioned the resolution, I can see the 0.026 cell size, which is a little bit high, but we'll get to that later. In here, I'm going to change this to nDSM, and then in my edit function chain, all I have to do to revert to the nDSM is remove this guy. Save, run, and then to confirm, shall I see it? nDSM, indeed, I see. And it's in a difference, by the way, so if I do this, there we go. The next step, as I said, is getting this data into the orthomosaic, and for that I'm gonna look a little bit on my orthomosaic, and I want you to notice something. I have a fourth band in here that actually got zero data. It was produced by the input imagery and it's not needed. So I first need to get rid of this, and then I want to add a true fourth layer, which is the nDSM here. And to do that, I'm gonna stick in here. I'm gonna leave my nDSM for our reference, and I'm gonna paste it again, and let's call it RGB nDSM. And in here, if we edit the function chain, I will need the RGB, so I'll put this guy here. I will need to extract the bands I told you about, so extract bands. Gonna drag and drop this in. I need band 1, 2, 3, perfect. The next I want to do is blend these, and that's a very easy one. I'm gonna go and composite, and you see composite bands. In here, I want my RGB first, so I'm gonna drag this in, and then I'm gonna drag the con in. The last step is now these are gonna be called band 1, 2, 3, 4, and that, if I'm gonna give this to a later user, it might be a little bit challenging. What is this? What is that? So I'm gonna click on another raster function, and that promise would be our last for this tutorial. Close this and drag and drop in here. So in here, I've got my composite bands, the 4 of them. All I wanna do is give them a name: red, green, I know the order, blue, and nDSM. And click OK. Auto layout, run this, and you know what, I want to save my project. Close this. I see black, but I'm fine with that because we might know what's the challenge, especially with the fourth layer. And look at this, everything is switched off. I can see my RGB. Now I want to verify that my nDSM is there, and to do so, I'm gonna, an easy way, click on the layer, right click at symbology. I can see the value of nDSM here, but I know it's a single band, so let's work it in a better way. I'm gonna go to stretch, and then in stretch I'm gonna get band nDSM, and we know the trick, right? Look at this. So this is now a band. When I want to export training data, I'm gonna use this 4-band imagery, where if I go to the source and check the raster information, I'll see that it got 4 bands. The pixel depth, keep that in mind. Do I need 64 or not? That's a topic we can dive into at a later stage. I might be able to downgrade a little bit. What I'm interested in is in the band metadata, and I can see these in here. I really hope you found this information beneficial, and it really taught you how to deal with multiple rasters and bring them together. We've seen how we can get elevation data, use it, and blend it with RGB data. I know we didn't do any AI for today, but that was the use case. This is a pre-GeoAI workflow. This is what we really need to move to the next step of exporting training data, training a model, and classifying imagery. And for that, stay tuned for the upcoming video. Please don't forget to hit like, leave your comments, subscribe, and I'll see you soon. Bye for now.